Now we're going to look at rewriting our confidence interval in a different notation. We want to write it as the mean plus or minus the standard error. The way we've been writing it so far is the lower bound of the interval to the upper bound. So in the case of this first problem we looked at earlier, it was the mean was 2178, but our confidence interval went from 2144 to 2211. Now what we want to do is write the mean in the middle and then write the amount the mean is away from each of those ends as our standard error. So our mean, 2178, we're going to start with that. Write that here. Then we're going to have our plus or minus, because we can either add to it or subtract, because it turns out that each of these two numbers here, this one and this one, are both the same distance away from the mean. So to figure out how far that distance is, let's go back to our calculator. We have 2178 minus, we'll subtract our lower bound, 2144.1, and we'll get 33.9 as our standard error. Now just to check that it is in fact the same distance away, if you take 2211.9 and subtract our mean, so if you take our upper bound minus our mean, 2178, you're also going to get 33.9. So no matter which way you do it, you're going to get the same standard error, and that's going to always be true. So you only have to do this once. So 33.9 is our standard error, and we'll write that right here after our plus minus. So we have our mean, which we knew from the beginning, plus or minus our standard error. So let's go ahead and do this one more time, actually a couple more times. In this problem here, we use the t-interval instead of the z-interval, but it works the same basic way. We have a mean that we're given, 314, so we'll write that in. And we'll have our plus or minus, because we can either add or subtract from the mean, and then our standard error. Now, in order to calculate that, we take our calculator out. We'll take our mean, 314, minus the lower bound, 291.13, and that'll give us how far away each of these endpoints is from the mean. And again, if we just wanted to check to see that it is in fact the same number no matter which way you do it, whether you use the upper bound or lower bound, we take our upper bound minus our mean, it's going to come out again 22.87. So we'll write that in. 22.87 as our standard error. And this is just another notation for writing the confidence interval. We have the notation up here as a range. Now we have the notation here as plus or minus. Each of them has their benefits. So this notation up here is good to say, well, I'm going to actually describe where the interval is that we think the mean is in. It starts here, it ends here. And that's useful in some cases. But a lot of times you want to know, what's your best guess of the mean? And our best guess is always going to be x bar, 314. However, how much are you willing to go away from that 314? Well, we're willing to say it's within 22.87, within about 23. How confident are you of that? We're 95% confident that it's within that distance of our original guess. So that's just another way of expressing it. It highlights the size of the range along with our best guess, whereas this one highlights the actual numbers that we're encompassing. So different purposes, but the one that you'll probably see more commonly is this plus-minus notation. The reason we started with this is it's a little bit easier to work with in z-scores, and that's the output our calculator will also give us using t or z interval. Let's do this one more time just to make sure we have it. Our t-interval spat out these numbers here. Our x bar was 8.8. Whenever you have a list of numbers, you're not going to know the mean ahead of time, but your calculator output will tell you. So if you just look at your calculator output right below your actual interval in the t-interval here, it'll say x bar equals 8.8. So that's how you know where your center is. So we take out our calculator. We have our 8.8 and I'm going to subtract our lower bound here. 7.73, I'm going to round up at 3, call that good enough. 1.066. So we're going to have 8.8, 8.8, and we'll write in our plus or minus, and 1.066. I'll have a plus or minus key here, so hand write that in. And again, that's what we're looking for. We have our standard error, this is called. It's the amount of variation that we're willing to have above and below the mean. And that gets plus or minus from the mean.